box is a funny concept. In the physical world, a box is finite and can hold only so much. It's not something people think about often, but in programming and computers, containers are unlimited. A single folder can hold endless patterns of data and innumerable files. To give an example, look at the computer or mobile device you're using to view this video. How much does it hold? Browse through the documents or your applications and just see how massive that computer really is. This is what makes computers amazing beyond their speed and flexibility. It's that they can take in practically any medium of data or content and reduce it to a size we can barely comprehend. Look at your flash stick. Even a barely decent USB drive can hold about 2 gigabytes of information. For reference, that's a rich text equivalent to over a billion letters and numbers, or 7.7 million tweets. So this practically endless storage space has revolutionized our day-to-day lives. Instead of printing out a single book that is about 512 kilobytes in size and about a half a kilogram in weight, we have 50 books on a 10-ounce Kindle. Using this knowledge, I went out on a task to prove two things: that infinite storage can apply to concepts like behavior, and that these behaviors can be extremely complex. Using the now humanoid robot made by Aldebaran, I made a program that had it playing the game Simon Says in the space of a single box. Here's how. The robot works on simple principles and commands. To start, it lies dormant on the ground awaiting tactile input on its head sensor. Essentially, it's on a loop that will not end until it receives a single yes or no piece of data that tells it has been touched on the head. Then it completes that execution and moves on to the next set of instructions, simple motor commands. These commands tell it to complete a series of motor movements in a specific order, double-checking the data with orientation sensors. When it completes this task, it sends a piece of data to the next section of code, which is also an input location. It awaits some sound input in a microphone sensor. When it receives sound info, this time in the form of the word Simon Says, it sends a confirmation signal to the program's next phase, also a sound input. This is where it gets tricky. The next input stage can take in multiple inputs and differentiate between them perfectly, at least most of the time. It sends this data to a different series of motor instructions for each pose, which then positions the robot exactly how I told it to. Then it sends the signal back to the Simon Says block for an endless repeating of the game. Simon Says, raise hands. Simon Says, sit down. Simon Says, raise hands. Simon Says, clap. Raise hands. Simon Says, raise hands. Sit down. Simon Says, look up. Simon Says, look down. He's looking down.
Look down involves standing up though.
Oh.
Interestingly.
Simon Says, raise hands.
That's my favorite.
Simon Says, clap.
Clap. Tell him to raise his hands again.
Raise hands. Simon Says, raise hands. Simon Says, sit down. Simon Says, stop. And that ends the program. So that's basically how it works. Start with some simple instructions and expound upon those instructions over and over. All computing is an iterative process that slowly adds over time. The first computers had kilobytes of RAM, but by slowly improving the technology and expanding the data, it became more and more advanced. That principle carries over to any aspect of computing. Advancement is allowed by two things:
Simon
that there is
Says.
always room for improvement, and that the canvas of
Look up.
programming and computing is infinite. There is everything to work towards and
Simon
everywhere
Says.
to work towards it.